This is R.D. Sharma's solution, class 11, chapter 30, derivatives, VSAQ, very short answer question. This is question number 8. Write the value of the derivative of fx, and fx is given like this, which is mod x minus 1 plus mod x minus 3 at x equals 2. Right. So first of all, we have to see x minus 1, x minus 3 in mod, where it is going to be positive, where it is going to be negative. That's the only thing which we have to do when we are having some modulus. So you want to have a critical point, just put as 0, x minus 1 equals 0, x is 1, x similarly x minus 3 equals 0, so x equals 3. This is another critical point. That is, before that and after that, x minus 3 will give you something, and same as x minus 1. So if you see, x equals 2. So 2 is in between 1 and 3. It's already given in the question. X equals to 2 you have to find out. So the best thing which I suggest is, always put this 2 here and see whether what is going to be positive, what is going to be negative. The only thing is this. For example, if you put here x minus 1, x equals 1. So you are talking about a range which is greater than 1, because 2 is greater than 1. So x minus 1 is related to 1, x minus 3 is related to 3. But in between we have 2. So 2 is greater than 1, any value greater than 1, and 3 is greater than 2. Or you can say 2 is less than 3. So 2 is greater than 1 and 2 is less than 3. So what does it mean? It means when we put, say, 2 minus 1, x minus 1, 2 minus 1, so it is going to give you positive. But when you put 2 minus 3, it's going to give you negative. I hope you got the idea. X minus 1, if you put value 2, just directly put 2, which I suggest is. 2 minus 1 is positive. So mod will give you positive. Any value, even if you put 1.5 or any value, is in this range, which is greater than 1, x minus 1 is going to give you x minus 1. But when you talk about 2 with respect to x minus 3, if you put 2, you put say 1, you put any value which is lower than 3, it's going to give you a negative x minus 3 when you take out this from the modulus. So it will be minus x minus 3. Okay, I hope you got the idea. It's minus x minus 3. So in this range 1 to 3, if x is between 1 and 3, x minus 1 will give you positive x minus 1, and x minus 3 will give you negative x minus 3 if you talk about modulus of these two functions. Right? So now in place of x minus 1, you can easily write x minus 1, but in place of x minus 3, you are going to write minus x minus 3. So let us put this x minus 1 positive and x minus 3 negative. So I am just taking negative here. X minus 3. X minus 1 minus x plus 3, cancel this xx, 3 minus 1 is 2. Now d by dx, you have to find out f dash x. D by dx of a constant number is 0. So 2, d by dx of 2 is 0. Okay. Coming to question number 9. Here, if fx is equal to x square by modulus of x, then we have to find out d by dx of fx. D by dx of fx. So same thing, x square won't matter much. Main thing is, first of all, x cannot be 0. This is very important. Okay, so we are taking case 1. X can never be 0. But x can be greater than 0. So mod x will be, x greater than 0, mod x will be plus x. I'll just change it. And x less than 0, so x square by negative x minus x. So I just change the plus this to be plus x. So only negative positive this will be. So this is positive x. Okay. And this is negative. So you have x and negative x. D by dx of x is 1. D by dx of minus x is minus 1. Minus 1. Minus will come outside. And d by dx of x is minus 1. So you have f dash x, and this will be 1. This will be 1 if x is greater than 0. X is greater than 0. And this is going to be minus 1 if x is less than 0. Right? Next is question number 10. Now d by dx of log mod x. Log mod x. So first thing is, let me show you the function first. Log mod x. We have to find out d by dx. So first we have to take case 1, case 2. Why? Because it is a mod x in mod. So x is greater than 0, x is less than 0. When x is greater than 0, that means we are talking about log x. Mod x, x is greater than 0, x is greater than 0, so mod x will be x, and here mod x will be minus x. X is less than 0 we are taking. So x is greater than 0, x is less than 0. Okay. So now put this, when we have x greater than 0, it will be log x. When x less than 0, it will be log minus x. Okay, now let us take the differentiation now. Log x is 1 by x. And log minus x is 1 by minus x. d by dx of log x is 1 by x. And d by dx of log negative x is, because if you assume it to minus x to be y, it will be 1 by y. And of course, and then you have to do this differentiation of minus x also. Okay. Please remember, you have to do minus x also. Right. So, but what you see here, that 1 by x and 1 by minus x, what does it mean? We just did minus 1 by minus x. Okay. So now you have, because log x is 1 by x, so you don't have to do minus x. I just said minus x, you don't have to do that. So log mod x, it can come x and minus x, so that is why you are going to write 1 by mod x. That is, mod x is x for x greater than 0, minus x for x less than 0. Okay. So you can just put it like this, 1 by mod x. This is the answer. Now question number 11 it is. Okay. F1 is 1. F dash 1 is 2. That is d by dx of fx is 2 at 1. And we have to find out the limit under root fx minus 1 by under root x minus 1. So first of all, these kind of, whenever we have under root something, we have to eliminate the under root. We have to multiply it by the RF, rationalizing factor. So I'm multiplying root x plus 1 for the denominator, root x minus 1, but the numerator is also root. So I have to multiply the numerator also, means numerator with the term which is your root fx plus 1. Okay. So root fx minus 1, so just multiply it by root fx plus 1 divided by root fx plus 1. Okay. For this one. For numerator, we did this one. For denominator, we did the first one. So a minus b, a plus b formula is there. A square minus b square. So you have fx minus 1. Basically root fx whole square minus 1 square. So root fx. And root x minus 1, root x whole square minus 1 whole square, root x minus 1. X minus 1. Now what is remaining? Root x plus 1 in the numerator and root fx plus 1 in the denominator. Now you see here, this fx minus 1, when we apply the limit, please remember, we have done first question, fx minus fc by x minus c. Fx minus fc by x minus c is f dash c. But this 1 we can replace by f1. Why? Because in the question it is clearly being said that f1 equals 1 and we already have a 1. So I am replacing this 1 by f1. Okay. So I'll just replace this by 1, because if you just apply the limit, it will be f1, 1 minus 1 divided by 1 minus 1, and that will not solve our purpose. So as I'm saying, fx minus fc by x minus c is f dash c. So here you have 1. So just put f1 because f1 is 1. So fx minus f1 by x minus 1. Now this is a proper differentiation only of f dash 1. Right? So this is f dash 1. And what about this one? This is f dash c, right? So that is why I wrote f dash 1. And what about this one? Under root. Now I'm applying the limit, so just put x as 1. So root 1, I'm putting x as 1, so 1 plus 1, root fx, that is 1. So this is 1 plus 1. Okay. So you have 1 plus 1 by 1 plus 1, that is 2 by 2. It cancels, you get only 2 by 2, that is going to be 1. What is f dash 1? It's 2. So this is 2 into 2 by 2, so you have 2 only. So 2 is the final answer. Question number 12 it is. So write the derivative of fx, and fx is given as 3 multiplied by 2 plus x, which is inside a modulus. So 3 into mod 2 plus x, it is asking at x equals minus 3. So first thing is x is minus 3, and this minus 3, how does it affect this mod 2x plus x? This is what you have to see. So 2 plus x equals 0, x equals minus 2, this is the critical point. So when you are seeing this 0 and this is the critical point minus 2 and you have minus 3 here, at minus 3 you have to find out. So the best idea is just put minus 3. 2 minus 3 is negative, minus 1. Okay, just put minus 3 and see with this 2 plus x is going to give you negative or positive. So even if you put minus 3 or minus 4 or whichever number, say 2.5 also, 2 minus 3 is what? There is negative 1. So negative you are getting. So mod 2 plus x will be negative 2 plus x. When you remove this mod, it's going to be negative of 2 plus x. So 3 into this mod I am just replacing minus 2 plus x. So minus 3 2 plus x, which is going to give you minus 6 minus 3x. Minus 6 minus 3x. Basically it's minus 3x minus 6. So you have this as the function now, and now do the d by dx. So minus 6, so minus you can take outside. This 6 is going to be 0, and you have 3x, so 3 will come. So you have minus 3, negative 3 you have. So this is how you are going to do it, okay? The best thing is, whenever you have this mod and some value is given, just put that value and see whether it is negative or positive. And just, if it is negative, remove the mod with a negative sign of that function. For example, we did 2 plus x, removed the mod and we just put a negative in front of it. Question number 13. So it's given if mod x is less than 1. This is very important because this will make the function differentiable. Otherwise it is not. Y is given as 1 plus x square plus x cube, and we have to find out dy by dx. So when we have dy by dx of 1 plus x square plus x cube, this series is a GP and these goes up to infinite. This is a by n 1 minus r. If for a is the first term, r is the common ratio. So what is a? 1. What is r? X by 1, x square by x, you can do x cube by x square. X is the common ratio. So a upon 1 minus r you have to do. So a is 1 minus r, so that is 1 minus x. So this is given here also. So this is the sum. Now we will find out the differentiation of this. But before that, if you see 1 minus x, mod x is less than 1. Mod x is less than 1 means x is between 1 and minus 1. That is how it is important. You cannot have x as 1. If you put x as 1, it will be 1 by 0, 1 by infinite. So I'm just doing the differentiation, it's just like what we have done earlier. So it will be minus 1 in front, 1 minus x to the power minus 2. Now we will do 1 minus x also, chain rule. So 1 minus x is 1 is 0, so minus 1. Minus cancels, you have 1 minus x, go square. This is the final one. Question number 14 it is. Let me tell you again, this mod x less than 1 is important here. You cannot just, because if it is given in the question, you cannot have x as 1. If x is 1, it will make your function not differentiable. So you have to be, if you are preparing for your competitive examination, say IIT or something, then you have to be very specific about this. For normal, examination, board examination, you can do like this. But for competition, this mod x less than 1, everything which is given in the question is important. You will be using it somewhere in your question. Okay. Now this is question number 14. If fx equal to log base is x square and it's x cube, log of x cube. The base is x cube. So we have to find out f dash x. So you know that log base a b, you can write it as log b by log a. You can do like this. Okay, base is this. Now we can write this as log. We have x cube here, and then we have log, and we have x square. So the question is, why do you do this? Because log is only differentiable when it is having base as e. Please be very careful. Base has to be e. And what is the power? Log a raised b is b log a. Log a raised b is b log a. So we can write it as 3 log x. I'm not writing base e, okay? So 2 log x gets cancelled. 3 by 2 is the constant. And differentiation of a constant is a 0 value. This is f dash x. Okay. So this is all about the exercise VSAQ. Thank you so much. Take care of yourself.